Hello, pre-calculus. Hope you guys are doing well on this day, enjoying your time. Well, welcome to our first online session. Hope you guys enjoy it and learn some things. What I want to start talking about here today is how to deal with the graph of tangent. What you see on the screen right now is a graph of the tangent function. Looks kind of crazy, but it does have a period to it. You see it repeats itself every pi in length. So not 2 pi like with our sine and cosine graph. This thing actually repeats itself every pi. I'm going to kind of illustrate that for you. So let me show you a picture here. And with this picture, I've highlighted a couple things about the graph of tangent. One is the asymptotes. What you're going to notice is that at negative pi over 2, I'll kind of sneak this in here, negative pi over 2, to positive pi over 2, you have your basic period of the tangent graph. These are asymptotes. And actually, every pi, they will occur. And this is going to be a little bit rough to sketch, but this will be the next asymptote in here. And it will occur pi later, which will be at 3 pi over 2. All right, and then again, pi later, it's going to go back to the next one, which will be, if we add pi to that, adding 2 pi over 2, give us 5 pi over 2. All right, so every period, every pi in length, you're going to have a tangent graph repeat itself. And the values that you're going to notice repeating are right here. This is the value of negative pi over 4 and negative 1. If you think on the unit circle, you remember that graph. Here we have 0, 0, obviously. And then right here is going to be pi over 4 and 1. These values are the basic values on the parent function of the tangent graph, and they repeat every pi. And so you'll notice those 3 values repeat themselves. 1, 0, and negative 1. And those pi values will change. The x values here will change to different angles, but the 1, 0, negative 1 will repeat themselves. So this is the parent function of the tangent graph. Now let's work on doing some transformations with this graph. If we notice here, bring some things up. Hopefully I don't get an avalanche of stuff falling here. But let me bring this up for us. All right, so what I'm going to do is I'm going to sketch a graph for you guys and see if we can show you how to do this. So say I'm given something like y equals 1/2 tangent of, say, 3x. All right, well, what happens with tangent is the value of 1 that I showed you is modified by this 1/2 right here. The y values will actually shrink. This is a vertical shrink of a half. Okay, so what we have is that's what this does. This is a vertical shrink of 1/2. Well, right here we have a horizontal effect going on here, and it's going to be reciprocal like we're used to, but it's a horizontal shrink of a third. Horizontal shrink of 1/3. All right, so what we're going to do is we're going to sketch this here, and this is kind of how you guys will do it with your homework. But you'll take your coordinate plane and try to draw that here. And what will happen is the period is 1/3 of what it was. If you caught on to what I said, the period for tangent graph is normally pi. So what happens is we do the reciprocal, we take this 1/3, we times it by pi, and we get pi over 3. This is now our new period length. Well, if you think, the tangent graph is symmetric with respect to the y-axis. So what happens is, instead of going to pi over 2 like it did last time, it's going to go to pi over 6, actually. And then it will go to negative pi over 6, will be on the other end of this. These are where the 2 asymptotes will now be. They were at negative pi over 2 to positive pi over 2. That was for a period length of pi. But this one, the period length has been shrunk by 1/3. So the period length is pi over 3. That means if we split pi over 3 in half, we'll have pi over 6. And negative pi over 6 will be the new asymptotes. Now 0, 0 is going to remain unchanged. It's going to be in the middle. But right here, we're going to be at half of pi over 6. Well, that's going to be pi over 12. So it'll be negative pi over 12, trying to sneak that in there. Now, we said this thing goes up to what? 1/2? Because it's 1/2 of what it used to be. This was normally at 1, but now we're going to go up to 1/2. All right, so let's think. Pi over 6 is roughly, it's roughly like a half, because 3.14 over 6, it's about a half. So I'm going to double this length. It's going to say this is about 1 right here. So a half is going to be somewhere in here. -1 probably down here. And then a -1/2 is there. Well, there we go. There's our next point. The next quadrant point's going to be, or coordinate point's going to be about down here. Then all you have to do to sketch one period is go between the asymptotes. Okay? That's a sketch of this graph right here. If you want to do 2 cycles, which you should be getting used to, you have to go pi over 3 more, which if you think about this, it's going to be, if we just space it out, it's going to be about there. And that was a pi over 6, right? So we're going to go another pi over 6, another pi over 6. It's going to give us 3 pi over 6, which if you think about that, that's pi over 2. That'll be the next asymptote. It's going to go up here. My spacing's a little bit off. We're sketching it. Right in the middle is going to be the 0, 0 point. Right in the middle of this will be at the half. Right in the middle here is going to be at -1/2. And all you have to do is sketch it. And it's going to look something like this. And it repeats itself every pi over 3. That is how you deal with a tangent graph. Okay? If you have questions, please email me. Hope you guys have a great time today. And again, let me know if you have any questions. We'll cover cotangent in the next video.